Dear friends, welcome to Infos. Welcome to another video from Oil and Gas Training. In this video, we are discussing about a new subject, pumps. You know that one, various pumps are using in hydrocarbon industry, oil and gas industry for various applications. So, from this videos onwards, let us discuss about pump operation principle, constructional details, control system, safeguard, etc., and various application, different type of pump, etc. Welcome to this video. What is the pump? Pumps are machines which supply energy to a liquid in order to move it from one place to another. The method that is used to supply this energy to the liquid determines the category into which the pump is placed, and the system between the pump and the liquid final destination defines the application. Pump enable a liquid to one flow from a region or low pressure to one high pressure, flow from a low level to higher level. 3. Flow at a faster rate. Pumps vary considerably in their size, construction, and principle of operation. There are two main categories of pump. One is a rotodynamic pump. One example is this one, commonly known as a centrifugal pump. This is one simple picture of that one. Other one is a positive displacement. In this category, both categories are various other types of subcategories are there. Let us see that one. See, look at that one. In rotodynamic, simply called common name is centrifugal pump. So it is centrifugal, axial flow, mixer flow, turbine flow. In our experiences in oil companies or hydrocarbon industry, we are regularly using centrifugal pumps. Let us discuss that one. In other cases, positive displacement. Both are in different operating principle. So in positive displacement, other subcategories are there, rotary and reciprocating. In rotary, there are gear, lobe, sliding vane, and screw. In reciprocating, piston, diaphragm, and plunger. So in our class coming lessons, we will discuss centrifugal pump mainly. In positive displacement, the two category, rotary and reciprocating, we will discuss in detail. So let us discuss on centrifugal pump. So simple picture is here. Suction side, suction is there, impeller is there, casing is there, volute is there, and discharge nozzle is there. So let us see what are the operating principle, constructional details, etc. on centrifugal pump. Also known as a rotary pump. Centrifugal pumps have a rotating impeller. This is the impeller. Also known as a blade that is immersed in the liquid. Liquid enters the pump near the axis of the impeller, and the rotating impeller sweeps the liquid out towards the end of the impeller blade at a high pressure. So liquid is entering from here and the impeller is rotating and creating a higher pressure and discharge to at a higher pressure here. For low flows and high pressures, the action of the impeller is largely radial. For higher flows and lower discharge pressure, the direction of flow within the pump is more nearly parallel to the axis of the shaft, and the pump is said to have an axial flow. The impeller is in this case act as a propeller. The transition from one set of flow condition to the other is gradual, and for immediate conditions, the device is called a mixer flow pump. In taking to positive displacement pump, look at the picture. It is a different principle it is working. We will discuss that one. A positive displacement pump moves a fixed volume of fluid within the pump casing by applying a force to movable boundaries containing the fluid volume. A variety of positive displacement pumps are also available, generally reciprocating and rotary type. The liquid is trapped in the spaces between the lobes and discharged into a region of higher pressure. Here the rotary type of positive displacement. A common device of this type is the gear pump, which consists of a pair of meshing gears. The lobes in this case are gear teeth. Here one example of a gear pump, screw pump, rotary vane, etc. In other case, it is a reciprocating pump. This is a reciprocating pump coming under the category of positive displacement pump. A reciprocating pump is a hydraulic machine which converts the mechanical energy into hydraulic energy. Here a certain volume of liquid is collected in the enclosed volume and is discharged using pressure to the required application. Difference between kinetic and positive displacement pump. This is a reciprocating pump and this is a centrifugal pump. What are the main difference? The main difference between the kinetic and the positive displacement pumps lies in the method of fluid transfer. A kinetic pump, that is a centrifugal pump, imparts the velocity energy to the fluid, which is converted to the pressure energy upon exiting the pump casing. This is the centrifugal pump picture. In positive displacement, pumps are also divided into two major pump categories. Earlier discussed that one, reciprocating and rotary. Reciprocating pump transfer a volume of fluid by a crankshaft, eccentric cam, or an alternating fluid pressure acting on the piston, plunger, or a diaphragm in a reciprocating motion. This is the reciprocating pump. The table below outlines some of the main differences between centrifugal pumps, reciprocating pump and rotary pump. Note that centrifugal, reciprocating and rotary pumps are relatively broad categories. The table below provides a comparison of features between these pump categories that generally holds true. Also note that the table lists typical maximum flow rate and head. It is possible to build special pumps outside the upper bounds of the pressures and flow rate listed, but such pumps would be prohibitively expensive for most applications. We will discuss in general applications and other conditions of centrifugal pump, reciprocating pump and rotary pump. First parameter is optimum flow and pressure application. Centrifugal pump is medium and high capacity, low and medium pressure. In reciprocating pump is low capacity, high pressure. Rotary pump, low and medium capacity, low and medium pressure. Then maximum flow rate 1 lakh GP gallon per minute is the maximum flow rate. In the reciprocating coming, it is 10,000 GPM, 10,000 plus GPM gallon per minute, and rotary pump also same as 10,000. Low flow rate capability, centrifugal pump is not usable for that one. Low flow rate. Reciprocating pump is can use in as a low flow rate also, reciprocating and rotary pump. Maximum pressure, it can go up to 6,000 plus psi. In reciprocating pump is can work much higher capacity, around 1 lakh plus psi. So rotary pump is a little bit lesser value, it is a 4,000 plus psi. Required a relief valve. In the centrifugal pump, not required. Reciprocating pump and both rotary and reciprocating, yes, it is a must relief valve. The reason is we are explaining in a coming slide. Smooth and pulsating flow. Of course, in centrifugal pump is a smooth flow, but in reciprocating pump is a pulsating flow. We are providing some additional equipment, pulsating dampener. And rotary pump, it is a smooth flow. Variable and constant flow. Of course, it is possible in centrifugal pump variable flow. Reciprocating pump is a constant flow. Rotary pump also in constant flow. Self-framing is not available or not fixed. Framing is required in centrifugal pump, but self-framing is available in reciprocating and rotary pump. Space conservation, require less space, and reciprocating require more space. Rotary pump required less space. Cost, lower initial cost, lower maintenance cost, and higher power required for centrifugal pump. In other case, it is higher initial cost, higher maintenance, and lower power required. Same like rotary pump. So other one is fluid handling. There are various fluid handling details are there, suitable for a wide range, including clean, clear, non-abrasive fluids to fluid with abrasive, high solid content, not suitable for high viscosity fluid, lower tolerance entrained gas. It is centrifugal pump application. So various applications mentioned here in reciprocating pump. Please read it, pause the video and read it carefully and understand. I request you to visit the your field where you are working and see that one, what are the different type of pump which is using in your field, and understand that one it is coming under the category of a centrifugal pump or positive displacement pump. In that category it is reciprocating or rotary, and what are the power requirement, and please read the nameplate, understand, and various inlet valve and outlet valve and relief valve, etc., to get a better idea. Centrifugal pump capacity. So the wide variety of centrifugal pumps manufactured offer a relatively large range of available capacity. Radial flow and mixed flow pumps are used for low to medium capacity application. For higher capacity application, axial flow pumps are capable of delivering flow rate in excess of 1 million GPM or 1 lakh GPM. Centrifugal pumps are also not stable at a low flow rate, although there are special low flow centrifugal pumps are available that can deliver the flow rate less than 10 GPM. However, extreme low flow application, positive displacement pumps are a better selection. Normally, higher application centrifugal pumps, higher flow rate centrifugal pumps are using, and low flow rate positive displacement pumps are using. So that's why it is mainly in chemical injection application we use this positive displacement pump. So reciprocating and rotary pump capacity. Reciprocating and rotary pumps are capable of capacity ranging from low to medium, with flow rate peaking at 10,000 plus GPM. In theory, reciprocating pumps can be manufactured to deliver more capacity, but they become prohibitively large and expensive at high flow rate. But both reciprocating and rotary pumps are also capable delivering product at extremely low flow rate, fractions of a GPM, making them particularly suitable for many chemical injection application. So coming to the consideration of pressure, centrifugal pumps and rotary pumps are best suited for low medium pressure application. Multi-stage centrifugal pumps can deliver at pressures of 6000 plus psi and may be the most economical choice at this pressure in high capacity application. A centrifugal pump pressure rise is limited to the shut-off pressure on the pump curve, which is always less than the design pressure of the pump and the piping system if properly designed. Reciprocating pump or positive displacement pump pressure. Rotary pumps are best suited for low to medium pressure application. Reciprocating pumps are usually specified at higher pressure services with capability of exceeding 1 million psi. In most application exceeding 1000 psi, reciprocating pumps are more suitable, particularly in low to medium capacity services. Why it is, this is very important safety aspects we are discussing now. Why it is necessary to install a relief valve on the discharge of the reciprocating or rotary pump. You can see that one, this is the supply source vessel, and pump is here, a positive displacement pump or reciprocating pump, and it is the discharge valve is there, and this is the relief valve, and the relief valve is return line is connected to the source. So what is the reason for installing a relief valve in a positive displacement pump? Because both reciprocating and rotary pumps will continually increase the pressure when pumping against a closed discharge to the extent allowed by the driver's horsepower. This can result in overpressure of the pump or piping component. So it is necessary to install a relief valve on the discharge of the pump capable of discharging the full capacity of the pump. So in any condition, accidentally close this discharge valve, so the pump pressure is tremendously increasing at a higher value, infinite value. So to avoid that one, to damage the pump and piping equipment, normally producing or installing a relief valve here in the discharge side before the discharge isolation valve. So you can visit your plant and see that one, a relief valve installed in a positive displacement pump. Where in the case of centrifugal pump, there is no need a discharge side relief valve. The reason is this one. The centrifugal pump's pressure rise is limited to shut-off pressure of the pump curve, which is always less than the design pressure of the pump. A relief valve is only needed if no other measures are provided to detect the low flow conditions and shut down the pump, prevent damage. The relief valve need only to be sized to pass the minimum flow rate required to maintain the stable flow and prevent the excessive temperature rise. So normally there is no relief valve installing in the discharge side of the centrifugal pump. So this is the important safety aspects for both positive displacement and centrifugal pump. Centrifugal pumps and most rotary pumps provide smooth non-pulsating flow, while reciprocating pump produce a pulsating flow. A pulsating flow requires special design consideration in the piping system. If the pump is not located near the suction source, then the acceleration head can contribute to a low NPSHA problem, that is a net positive suction head applications problem, which may require installation of a suction stabilizer. A pulsation dampener may need to be installed in the discharge piping to reduce the pressure surges resulting from the pulsating flow. Centrifugal pump, variable or constant flow. Centrifugal pump operate on a variable flow, variable head curve. As the discharge pressure decreases, the pump delivers higher flow rate. Centrifugal pumps are favored where the process conditions often require varying flow rate. For example, a level control valve must throttle the flow rate from the vessel to maintain a constant level in the vessel. A centrifugal pump is well suited to handle this process condition. So in the using the control system or level adjusting or level controlling in a tank, centrifugal pump is most suitable in that situation. At a given speed, reciprocating and rotary pumps operate at a constant flow rate regardless the discharge pressure. There are specific applications that require either constant flow or variable flow. Metering pumps rely on constant flow at varying pressures, which make reciprocating pump and rotary pumps suitable for this application. Piston pumps used for metering will often use an adjustable stroke length to allow the operator to vary the flow rate to meet the system requirement. Same thing in chemical injection pump also, like piston pumps are using, and adjustable stroke is there to adjust the stroke rate, increasing or decreasing the chemical injection rate. Whereas a positive displacement pump would either require a continuous recycle or suction a variable speed driver to accommodate variable flow. In positive displacement, minimum recycle valve will be there, minimum recycle system will be there to the suction, or variable speed variable frequency drive installed to adjust the variable flow. So next is self-framing. So reciprocating and rotary pumps are self-framing. This is an important consideration where a frame cannot be maintained on the pump. In centrifugal pump are not inherently self-framing, although some manufacturers do specifically design the self-framing unit. We will discuss the details of framing to prevent cavitation, etc. in centrifugal pump separate videos. Here the symbol pictorial representation of there, and centrifugal coming need a self priming requirement. So we will discuss that one in later. So cost consideration, the reciprocating pump will generally have higher initial capital cost and will require more space relative to the centrifugal pump or rotary pump. The reciprocating pump will generally have higher maintenance cost relatively centrifugal pump or rotary pump. The centrifugal pump will generally have higher annual power consumption cost relative to the other two pumps. But the other pumps are lower in efficiencies. A pump that is selected to an application outside its optimum operating parameter will almost certainly not follow this rule. For example, a rotary pump operating in a higher pressure abrasive slurry service would probably have higher maintenance cost than a properly selected reciprocating pump. The close running clearances, particularly for higher pressure service, required in the rotary pump would likely result in the premature wear and frequent maintenance. The fluid handling differences between both pumps. Centrifugal pumps are suitable for transferring a variety of fluids ranging from clean, clear, non-abrasive fluid to abrasive slurry. However, centrifugal pumps are not best choice for pumping higher viscous fluid due to dramatic drops in efficiency at high viscosities. Centrifugal pumps are not normally specified for higher viscosities. Centrifugal pumps are also not well suited to pumping entrained air. Most centrifugal pumps can handle up to 2% of entrained gas, and specially designed pump can handle about 10%. So in case of reciprocating pumps are well suited for transferring clear, non-abrasive fluid as well as abrasive slurries. In fact, the relatively low viscosities, low velocities and moving parts within a reciprocating pump make it particularly resistant to erosion in an abrasive slurry application, provided that a pump is properly designed for the service. Reciprocating pumps maintain high efficiencies when pumping highly viscous fluid can easily handle 50% and higher volume of entrained gas. Rotary pumps can also handle high viscosity fluid and high volumes of entrained gas. In fact, many rotary pumps operate at their best efficiency at higher viscosities. However, rotary pumps are not well suited for pumping corrosive fluid or fluid with abrasive fluid because close clearances between rotating and static pump components. So the summary is coming, and one fact that must always be remembered: a pump does not create pressure, it only provides flow. Pressure is just an indication the amount of resistance to the flow. There are many different subcategories of pump within these broad categories, and there are many regions of overlap where multiple type of pumps in the same category and even in different category would be suitable. Since every pump application is unique, each of the factors that influence the pump selection must be considered in detail. Thanks for watching this video. We will coming with more slides, more videos from details of the various applications and constructional details and operation principle of centrifugal pump and positive displacement pump in coming videos. Thank you. Have a good day.